Welcome back to my favorite people, and thank you very much for watching this lecture video. I'm going to try to show you how to use the Frost circle and to predict whether one molecule is aromatic or anti-aromatic. And we're going to start with this. So the molecule that we have is made of 3 carbons. So here you go, 3 carbons. Next, it says it has a double bond. And it says go with an ion version of it. That means our carbon, this carbon, it has a lone pair. So we have 1 pi bond and 1 lone pair. So we have 2 pairs, and 2 pairs means 4 electrons. Okay, so I'm gonna say, is the molecule flat? Yes. How do I know is it flat? Because the hybridization of each carbon is going to be sp2 hybridization. And next thing is, do we have cyclic molecule? Yes, we have a cyclic. Do we have a p orbital on each carbon atom? Yes. And number of electrons are following 4n. And in this case, n is going to be equal to 4 divided by 4. It will be 1. So this molecule should be anti-aromatic. Okay, that's the Huckel rules. But how about the Frost system? The Frost system says draw a circle. Okay, so let's go with this one. We're going to draw a circle. Next, we will draw the molecule in a way that's here, in a way that it says one vertex should be pointing down. Okay, so one vertex should be pointing down. Okay, so here you go. One of them is pointing down. Okay, next, divide this circle to 2 half. Okay, so I go, let's say this one, it will be the right way to chop it. Okay, next, I'm going to call this one E equal to 0. E equal to 0. Wherever we hit the circle, that means we have a pi system, a pi orbital technically. So I'm going to say here we have 1 pi. That's going to be the second pi. And this one, it will be the third pi. Okay, so first pi, it will be here. That's going to be the second pi. And that one, it will be the third pi. Okay, now, how many electrons do we have? We have 4 of them. Start with lowest orbital. Give it 2 electrons. I go 1, 2 electrons. Out of 4, I used 2 electrons. So now I'm left with 2. What do I do with those 2? I put 1 inside this orbital and 1 inside the second p orbital. So the pi orbital, forgive me. And so now I got 1 orbital that is fully occupied and 2 are singly occupied. If you get singly occupied orbital, the system, it will be anti-aromatic. Okay. Now, what will happen if we turn this one to a positive instead of negative? So right now is -1. Okay. If I turn this one to positive, in that case, we will have this. So we will have such a structure. This is the structure is going to be. We will have a pi bond, but this carbon, it will have a positive charge. So I have 1 pi bond and empty orbital. So 0 lone pair. So that means I have 2 electrons. Okay. Totally, I have 2 electrons or 1 pair. Okay. And so that means this electron, that electron, it will be gone. The electron also, it will be gone. Now, look to the highest occupied orbital. Pi 1 is occupied. And so we have 1 pi orbital. And that pi orbital is fully occupied. And the top are empty. And if that's the case, we say we are dealing with aromatic compound or species. Okay, so look to the highest orbital. If it's fully occupied, okay, fully occupied, that's good. It will be aromatic. and or if it's empty, again, it will be aromatic. Now, if it's singly occupied, then you are dealing with an anti-aromatic, and the system will be unstable. Now, what if I put only one electron? If instead of making giving 2 electron, or taking 2 electrons from the system, just give it 1. That means you will have a radical. And if you have a radical, for example, this electron, it will be gone. And if you have only 1 electron inside that orbital, and again, that system, it will be unstable. So it will be anti-aromatic. That means it will be so reactive compound. Okay. Now, if I go back and compare it with, compare this 4 different compounds, and the cyclobutadiene, and it has 4 electrons. So I go 4 electrons. I'm going to spread those 4 electrons. 2 of them, I will put them inside the pi 1, and then I'm left with 2 more. Okay, I get 1 and 2. So I have 2 orbitals that are singly occupied. Is it aromatic? No, it will be anti-aromatic. How about tetraene? The assumption here, the molecule is going to be a planar assumption, and this molecule is capable of getting non-planar geometry. Okay, if the assumption is a planar, and in that case, I have a cyclic molecule, and the molecule, it has 4 pi bonds. That means it has 8 electrons. So this one is following 4. N is equal to 8. So N is going to be equal to 2. Okay. And so we are following Huckel rules. It's a cyclic. We have a p orbital, and a p orbital on each carbon atom. Now, when I draw the Franz diagram, I can see that I have 1 electron inside pi 4 and pi 5. And because I have singly occupied orbital, this system, it will be anti-aromatic. And now, third one, I just practice it for you. And as you see, we have empty orbital here, and the highest occupied orbital, it will be pi 1. And because I have fully occupied or empty orbital, I'm going to say this system, it will be aromatic. And how about cyclopentadiene anion? Okay, this one, it has 2 pi bonds and 1 lone pair. So totally, we have 3 pairs. Means we have 6 electrons. So we are following 4n plus 2 equal to 6, and n is going to be equal to 1. And so I'm going to assume this molecule will be aromatic. Let's prove it. And we have 5 carbon atoms. So I go 1, 2, 3, 4, 5. Here you go. We have 5 pi bonds. And 3 of them are fully occupied. 2 of them are empty. I don't have singly occupied orbital. So this system is going to be aromatic. And as you see, it says it is aromatic. And this is going to be end of this lecture. And